And I will.
Sorry, I started the recording so that we have this for future viewing if needed.
All right, that sounds good. So what I do usually is that I said that we're recording just in case, and then at the end we decide. And that's just to, make sure that everybody's comfortable, that everybody can ask all the questions that they want, and they don't feel pressure that, ooh, I'm gonna ask a question and I'm being recorded. In the end, if everybody agrees, then we'll just share it. But then for now, we're just recording just in case, if that's okay.
Perfect.
Yeah.
That works.
Yeah. In the past, too, we've been able to edit out particular people if they didn't want to have their question recorded. So that's an option, too, if it comes to that.
Awesome. Yeah, that works, too.
Yeah. Well, maybe I'll just, since it's about 4 o'clock Eastern now, maybe I'll go ahead and introduce myself, and then we can introduce Miguel and start off the workshop. So for those of you who don't know me, my name is Anna Weber. I'm the student and postdoc representative for the Society of Conservation Biology in North America. If you're not familiar with the organization, it is really great. They bring together people from all kinds of folks from all different fields who are kind of conservation minded. So it's a really good group to be a part of. We are, this is the North American region of SCB. So I'm just going to put a couple of links in the chat in case anybody's interested in the organization. So here's the regional site, and there's also SCB Global, which is there. And then here is my contact information if you have any questions. Other than that, I'm really excited that Miguel, that you're here and ready to help us with this workshop, and thank you all of you for coming. And I think we can go ahead and turn it over to you.
Awesome. So first of all, I'd like to know for how many people this is the first time that they're using R. And you can either reply or just use the emoticon with the thumbs up or something like that. Just want to know for who this is the very, 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 very first time. All right, we got some, because if this is the very first time you're using R, that's awesome, because this is designed literally for you. So, so I teach, I often joke around that I teach R for a living, and that's not necessarily true, but I do a lot of R in my courses. I teach quantitative wildlife ecology, I teach population ecology, I teach graduate classes with R. But sometimes, and I've taught this like 1-hour courses before, and something that I like to do right at the beginning is sort of to start like managing expectations. The metaphor that I like to use is the musical instrument metaphor. I don't know how many of you play musical instruments, but so for example, if you're playing the guitar for the first time, you're getting a guitar for the first time, chances are that in the first hour, you're not going to do the solo for November Rain of Guns N' Roses just in the first 45 minutes to the hour. And I like to use that very same metaphor because in R, it's just like that. Learning R, learning computational programming, learning statistical programming, it's very similar, right? It's something that takes practice. It takes, a lot of like trial and error and exploring and all that. So what we're doing today will be analogous to picking up the guitar for the first time. Right? So you're like sort of learning how to tune the strings. You're sort of learning, how to pick a note like that, not like that, but just pick it in the right way, what the different notes are and something like that. So you will have more knowledge than before, but definitely I wouldn't be expecting to do like super crazy guitar solos by the end of the hour. But we're going to try to still have fun in a way, if that works. All right. So does everybody install R and RStudio in their computers? All right, so I'm going to start first just doing a very, very brief sort of getting our bearings on RStudio. Actually, if you're opening this for the first time, you may be not seeing this window. So you're probably seeing something like this, very plain, very wide, and for some people, very scary. Because, only people that were raised in the 80s or the 90s are comfortable with that thing flashing, and that's it. But that's okay. The first thing that I will do is just open here an R script. probably gonna do, and I'm gonna explain in a second what it's R, what it's RStudio. But for now, my recommendation is that you work writing in this part of the script. But whatever you write there is gonna be run in this bottom part of your screen. All right. Any files, any things that you're putting in the memory, actually, you're gonna be able to see it in this part of your screen over here. Okay. All right. So for example, one of the good things that we can do with R is use R as a calculator. So I can do 2 plus 2, and feel free to follow what I'm doing on your end. And if you have questions, just raise the hand and we'll stop as much as we can. And if I do that, I can just go over that, do run. And if there's justice in this world, it's gonna run here and it's gonna give me 4, as we've done for many years, right? So it works as a calculator. And I can do other stuff. I can actually assign things. I can say A is gonna be equal to 2. So now every time I do A and I can do run, then A is gonna be equal to 2. So I'm going to mention 2 things before I go into, I prepare some slides to sort of guide the things, but there's a couple of things. One is that one of the things that we should always be doing is writing comments like that. And note that I'm using this hashtag, or we used to call it the pound sign, because whatever you write after the pound sign, R is going to ignore it when you're running. Like, for example, I can run all this, and you'll see that whatever it's in the memory is 2 plus 2 and A equals 2. That's it. So R is ignoring everything that it's here. But this is likely the most important thing that you're going to write in your code are your comments. They say that your most important collaborator is your previous self, but your previous self doesn't answer emails. So sometimes, we write code, we have this very nice analysis and everything is working. And then you open it like 3 months after and it's like, what in the world I was thinking when I was doing that? But if you write a bunch of comments, that actually goes away because you know exactly what you were doing and why. So one of the good practices is to be super, super organized with your code and comment. They don't charge you by the comment, right? So you can comment as much as you want in your code. All right, so I'm gonna stop here. So I'm gonna go back to my slides. My slides have code. So whatever I do in my slides, feel free to do it here and then run it. And you can run it here by just doing this run with your mouse, or you can just do Command or Control Enter, and it will do it the same way. All right. All right, I'm gonna stop here and see if there are any questions. Or comments. All right, so I'm gonna go to my slides and I'm gonna do this and I'm gonna do full screen. Is everybody seeing an R basics thing on your end? All right, awesome. All right, so a couple of R things. So what is R? Well, I joke in my classes and R is a pirate's favorite letter. But in addition to a pirate's favorite letter, it's actually a language. It's a programming language, an environment for statistical computing. It's an object-oriented programming language. In a way, I want to say, quote unquote, similar to like Python or C++ or Java. All of those are object-oriented programming languages. R is super, super popular for its statistical component and also for its graphing and data visualization component. There's some history to it. R is actually a rewrite of the language S and S plus that were developed in the Bell Labs in the 80s. So Russ Ayaka and Robert Gentleman from New Zealand actually rewrote the whole language from scratch. They made it free and they name it R because R is the letter that comes before S. And why use R? So R is a super powerful tool. You can do a lot of really crazy stuff in statistics, mathematics, and graphing. And R is free as in candy and free as in speech. And what do I mean like free as in candy and free as in speech? When we say free as in candy, it's like you don't pay for the candy, right? So when anybody says free candy, you're not expected to pay. In the same way, you don't pay for R. There's everything. It's there. It's free. You don't pay for it. And it's free as in speech in the sense that you can use all the packages. You can use anything in R, and more than use it, you can actually modify it anywhere you want for both um, commercial and non-commercial issues, whatever. You can do whatever you want with it, right? So it's free as in candy and free as in speech. And one of the things that I really like about using R or Python or any other of these languages is that it allows for replicability. That means that you do your analysis, and because you're writing your script, people can go and replicate whatever you do. So Peter or John can just go back and look at my code and say, let's see what Miguel did, and just check what I did, either because they just really want to check if what I did was right, or because they want to, borrow some of the same ideas, some of the same analysis, so they can go to my code and replicate it. And that's hard to do when you're using spreadsheets, for example, or you're using Excel or any of those, right? Because those that require for some clicking and all that, and unless there's somebody like filming you behind, seeing where you click, it's really difficult to replicate what you did. But in R, because we have a script, it's super easy to replicate and see very transparently what you did in terms of stats. So why some people don't love R? There's some reasons. One, it has a learning curve. That anything that it's worth to do in life has a learning curve, so I wouldn't be super negative about it. It doesn't have a graphical user interface. Like, for example, you don't click and point and do things very explicitly. Everything is through code. So if you don't have a lot of experience doing computational stuff, you didn't do programming in high school and your undergrad, this actually might be new. And some people get a little bit uncomfortable at the beginning. So there's some technical aspects. R used to be very slow and memory hungry. Now with these new computers, this is not a problem anymore. Computers now are super fast. The other thing that some people don't love R is because it's built by the community and there's no organization behind it. So contrary to SAS, for example, it's another statistical package or another statistical language, there's an organization that, they guarantee that everything will be done properly. R, in contrast, is done by folks like us. We just build packages, we build things, and they come without any guarantee, but we are really good at it. We have a really big community, and because everything is open source and all the packages are out there, people like us can go look at the code. If we find a bug, we can report it. And in a way, it may actually be even better, I think, than some of those like proprietary software. So some people don't like it because particularly some branches of the federal government, they rather have something that has a company behind it. But in academia, it's super common. All right, let's see. So what's the difference? So you're supposed to download R, install R, and also install RStudio. So R is the programming language, but RStudio is the integrated development environment. So basically, it's like a beautiful and nice way to do R. You can actually do R in the console of your computer, no problem. But RStudio makes it easier. You can actually see parentheses in different colors, functions or stuff in different colors. That actually makes it easier to interact with the language. So that's why we usually use R through RStudio. But there are other ways to do it. There's also other IDEs, like, for example, there was Atom for people that use Linux, and you can use R in Atom, or you can use Visual Studio Code, and you can do R in those too. Some people use Emacs, and you can do R in Emacs too. So there's different options there. All right, so let's start doing some code, and you're gonna see some code here on my slides. Feel free to just practice those on your end on RStudio. So as we said before, the first thing that we can do is just very basics. We can use it as a calculator, and we can just do, 1 plus 2, 1 minus 2. In R, the multiplication is that star, and division is that that dash. So you can use it as a very, very simple calculator. We can also do a little bit more complicated computation, just like this one, and note that the order of operations is pretty important. And I'm sorry that you did that, I don't know, in high school, or if you did that in your undergrad or whatnot, and you don't remember very well the order of operations, but this is the kind of thing that it's going to be important here, because depending on the order of operations is that you're going to have the right answer or not, all right? So something to think about, order operations are important. And we can do even more complicated things like this, where you put things in parentheses, so the equation does exactly what we want it to do in terms of orders of operation. So first take-home message, R is basically a calculator, and you can do what you do with any calculator. But here's when it starts to get interesting, is that you can have variables, right? You can assign things to variables. So for example, here, I'm assigning 2 to the variable A, and I'm assigning 3 to the variable B, okay? And now, if I do A plus B, I get 5, because in the background, what it's doing is that it's doing a computation of what A means and B means in terms of what I did in the computer, okay? And then I can do a little bit more complex calculations. For example, I can say C, I assign to the variable C whatever I had stored in A times 2 divided by 3 minus 1. So I can do all sorts of complicated calculations and get a result. And of course, I can also do calculations only with variables and get a numeric answer. Okay. Any questions so far? I get a message here in the chat. Say, why will you use? Oh, that's a really, really, really good question. So in the Harley Weekend manual how to do R, most people like to use this the arrow symbol instead of the equal. They might actually work the same, particularly if you're outside of functions. They might actually work the same, but in terms of how it looks and how people understand code better, the arrow might actually be better and preferred. Actually, they said that you should write code as if another human is reading your code, right? Because for the machine, it doesn't really matter. But if you're sharing your code, you're collaborating with somebody in your code, actually the arrow makes it visually a little bit better for the eyes. Good question. All right. So we went through the basics of variables. Now, the other cool thing that we can do with R is we can use functions. And functions are a set of statements that perform a particular task. And there are probably millions of functions in packages in R, right? There's functions to do anything that you want. There's functions to calculate means and variances and standard deviations and maximum likelihoods. There are functions to estimate how many animals are out there in a population. There are functions to do there's functions to do pretty much anything, right? We're going to start simple here, and we're going to use a simple function here, which is to calculate the absolute value. So the function in this case is abs. And this is the function, and whatever is inside the function, we're going to call it the arguments. And this is a function that only needs one argument, which is the number for which you want to calculate the absolute value. So you do abs, parentheses, parentheses, and inside you put the number that you want to calculate the absolute value, and you get 5, which is the absolute value of -5. Okay. Another common one is sum, which is literally going to sum all the numbers that are inside the parentheses, like 1, 2, 3, and 4. If you sum them, it's going to be 10. And like that, there's literally millions of different functions in R. Okay, so functions are a set of statements that perform a particular computation, a particular calculation or task. And these are the arguments on the function, and the function is usually outside, and then whatever's inside the parentheses are the arguments. Another common function is the function round. But of course, we're not going to do all the functions. We're just doing examples so you can get a taste of it. And round, this is pi 3.1416. But if I do round, it's just going to round it to the nearest integer. But if I add the argument digits, then it's just going to give me the number of decimal points that I want. Okay, and this is important if you're doing calculations and you want a particular type of precision. You only want like 2 decimal points or 3 decimal points. You can just set that up with the round function, right? All right, we already talked about comments, and comments are super, super important. I feel like that comments are likely the most important thing, and I'm of course exaggerating, but it's trying to make the point across that those comments are super, 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 super important. And the more you comment your code, the better you're gonna feel in the future when you're going back to your code. All right, so let's talk a little bit about data structures. And data structures are ways to organize data in R, and there are multiple types of data structures. We're going to start with the simplest one, which is vectors. Vectors are like one-dimension way of combining data. So here I'm using the variable lizard's weight. I do a lot of research on lizards. I study actually malaria in lizards. So sorry if you're going to see 1 or 2 examples about lizards. Lizards are fun, so that's okay. So here I'm saying this variable lizard's weight, it's going to be equal to this thing, right? And here I have 3 values, 2.25, 4.45, and 1.75. And I'm using the C here to say combine. That's the way that I tell R to know that whatever I'm doing here is just the combination of these values, okay? So the combination of the string of these values, we're going to store it in lizard weights. And that's how R knows that this is going to be a vector, okay? So now lizard weights, instead of being just a simple 1 value, as we did before with A, B, and C, it's going to contain 3 values in this case, 2.25, 4.45, and 1.75, all right? Everybody with me? All right. So how do I access a specific value inside a vector? Well, we can use the brackets. And I say, give me in the lizard's weight vector, whatever it's in the second position, right? So that's why we have brackets too. So I have 1, 2. So whatever I had in the second position is going to be 445. If I wanted the first one, then I'll just write here 1 and I'll get 2.25. If I wanted the third one, I'll get 1.75. And if you write 4, then your computer is going to explode. Now it's not going to explode, but it's just going to give you an error, right? Because there's only 3 values here. So if you do 4, actually you can do it. Go and do it in your computer. If you're following this, go do lizard's weight in the position 4, and you're going to get an error. And actually that's a really good practice, because something that we need to get used to when using R at the beginning is getting used to getting errors. Errors are common. I've been using R for many, many years, and I get errors all the time, and they're fine. So we need to start breaking this sort of feeling that, oh, I get an error, that's a bad thing. Actually, in R, it's just a message saying that something it's not functioning as it should. And it's actually a good thing, because now you can go and fix it. All right. Another thing is that I can have a variable within another variable, right? So here I'm just calling this thing var1. And I'm saying var1 is going to be whatever I had in lizard weights in the second position, which we already know that it's 4.45, multiplied by 100. Okay, so I can actually define a variable as a function of another variable and some sort of other calculation. So I can have variables within variables. One thing I'd like to mention about variable names is that, you know, it will be easier, you know, to just write A, B, and C and things like that. But, you know, a year from now, you will not remember what A, B, and C are. So it's always a good practice to have names that have some sort of meaning. Okay, so usually we have names for variable names like this one. And if you're writing functions, we usually use verbs when writing a function, right? This function calculates abundance. So you use calculate abundance, and that's the name of your function. And in this way, lizard weights or lizard sizes or lizards, I don't know, whatever, lizard something, but always try to use some sort of useful or meaningful variable name. So this will actually be a bad variable name if I'm coding stuff for my stuff, because variable 1 can just be anything, all right? And the other thing is that you can also apply functions to variables. So for example, if I apply the function sum to lizard weights, what it's going to do is going to sum everything that it's inside lizard weights. So it's going to sum 2.25, 4.45, and 1.75. All right, and there are other data structures in R. We are obviously not going to cover them all. We only have like 45 minutes in this introduction, but we did vectors, but you can also do matrices. You also can do lists. Lists are pretty cool because in lists, you can have multiple types of data structures inside of the lists. So they're super, super useful when you're coding stuff that is a little bit more complicated. And we're going to do a little bit of data frames in a second because that's sort of what do you say in English? Bread and butter of data analysis here. That it's the closest thing to the way we think about spreadsheets. Okay, but you can have all of these types of data structures in R. All right. The other thing I like to touch here in this so let me just stop here for a second and see if there are any questions from folks. Questions, comments. All right. Oh, there's a question in the chat. How does a vector differ from a list? All right, so that's a really good question, Leah. So a vector can only be one thing, right? A vector can only be either numeric or it could be a series of strings or words, but it can only be a series of either numbers or strings. A list, you can have everything. You can have a list, for example, with 3 elements, and the first element be a vector, the second element be a single number, and the third element be a data frame, for example. So there's no restrictions. So lists are super, super free. You can do pretty much store anything as a list. And of course, I mean, if you're doing something simple as this, then a list might actually be an overkill. But when you're working with complicated data or complicated data frame, they are super, super useful because you can have multiple types of data frames stored in a single object. And that's particularly useful. Good question, Leah. Does that answer your question? Awesome. Right, what else? Any other question? By the way, you guys are kind of like my heroes. You want to do R on a Friday afternoon, almost, and actually late in the afternoon. That's pretty awesome. So I gotta give it to you. All right, any other questions? All right, so let's start doing some logic operators, which is what makes R super, super useful and actually even better than working with spreadsheets. So again, we have the same vector of lizard weights with the 3 values. And if I do lizard weight greater than 2, it's going to go and check if if each one of these values meet this criteria of being greater than 2. For example, it's 2.25 greater than 2. True. It's 4.45 greater than 2. True. Is 1.75 greater than 2? No, false. And this looks super simple, but it's super, super useful when you want to do an analysis just in a portion of your data. Something that we do a lot in my lab, for example, is that we want to do an analysis only on adult lizards, for example. Well, what we do is just give me the lizard data that is greater than 40 millimeters in SVL, and that will only give me the adults. Or give me only the little ones, the ones that are smaller than 40 millimeters in SVL. So that's super, super useful to just do data on and also if you want to query your data in multiple ways, these logic operators are super useful. So another thing is that I can query the data, I can query the vector using logic operators. And now I'm entering into the conversation these brackets. And the way I want you to think about, or I don't want you, but I suggest that you think about these brackets is the word where. For example, here I'm saying, give me in lizard weight, give me the values of lizard's weight where lizard weight is greater than 2. And that's how you can think about these brackets, okay? So give me the lizard's weight where lizard weights are greater than 2. And in this case, it's just going to give me 2.25 and 4.45 because 1.75 is false, right? It doesn't meet that criteria, all right? Does that make sense? I have a question in the chat. Oh, it's a smiley face. I'm going to return your smiley face. All right. What else? It also allows for comparison among data types, and I'm doing here the same example, but now instead of greater than 2, less than 2, right? Give me the lizard weights where the lizard weights are less than 2. And of course, in this case, the only one that meets that criteria is 1.75. And actually, there are other multiple logic operators. There's the equal, which means equal to. So for example, if I do here, oh, this is a good quiz. So if I do here equal to, what I'm going to get here?
Like NA.
Yeah, there's nothing, right? So give me the lizard's weights where the lizard weight is equal to 2. I'm going to get nothing because I don't have anything equal to 2 over here. Now, if I would have done 2.25, then I will get this value over here. Must you repeat the vector name within the bracket? Yes, because that's the way you tell R, you know, the criteria comes from that particular vector. Okay, so yes, you have to repeat the vector name inside. I know it's like writing more, but still better than a spreadsheet. All right, so we have other ones different from greater, less, and in this case, greater or equal to or less than equal to. You can use all those types of operators to query your data. Okay, now let's do a little bit of and or. And you probably know where the and is usually above the 7th key, but something that I often get in my classes that folks don't know very well what this like vertical bar that means or in R is. And if you look above your enter key, you're gonna see something like this. So if you do shift and that should give you your or. All right. So if this is the first time you're using this, congratulations. Now you're using most of the keys on your keyboard. All right, so let's do an example here. So this is an example of dolphins. I had a master's student that graduated a couple of semesters back, and she was working with dolphins in Florida. So I'm not a marine scientist, but she really got me into thinking about dolphins. Dolphins are pretty cool. But anyway, so we have some sort of measurements of dolphins here, of female dolphins. And I have these values over here. And let's just say which dolphins in this data set have a weight between 190 and 220 kilograms, okay? So that's the question that I'm trying to address here. So how will I do that? So this is my data, right? And I only want the ones that are between 190 and 220. So from the perspective of R, this will mean that I'm looking for the animals that are greater than 190, but smaller than 220. All right. So I'm looking for animals that are greater than 190, but smaller than 220. In other words, I'm looking for the animals that are greater than 190 and less than 220. Okay. So in this case, I sort of follow the same logic as before and say in the vector dolphins F, give me the data from the vector dolphins F where dolphin F is greater than 190 and dolphins F is less than 220. Okay, so here I'm combining two of the things that we learned. We learned these logic operators, and now we're learning about this and or. Okay, so what would be the difference between, let's see, if I use an or here instead of an and, what will be the difference?
Wouldn't it retrieve if you use an and, it retrieves only the ones that are above 190 and below 220, but if you use or, it'll return both things that qualify for either.
Exactly. It will be like either they're greater than 190 or less than 220. So basically I'm going to get all the values, right? Because they're either greater than 90 or less than 220, but 220 is going to be included because it's greater than 190, and 190 is going to be included because it's less than 220. So if I use or, basically all the numbers will be here. All right. Cool stuff. So the other thing I want to talk to you about, oh, I have a question in the chat. Can we store the results of one of these operations as a new vector? Yes, you can. Let me just go back. That's a really good question. Yes, you can actually write here, for example, dolphin, you can make up the name, right? Dolphin's condition equals this, and it's going to store these three names in a new variable. Yeah, good question, Leah. And yes, you're welcome. All right. Now, and again, I mean, I'm going really quickly into the different topics. This, this whole thing can be a full semester course, but again, we're picking up the guitar for the first time. So we're just looking at a couple of things that hopefully will get you curious about these things, and you can just go home and practice. So we're going to talk a little bit about R packages. They contain code, functions, data, and documentation. They're standardized. They're stored in the comprehensive R archive network, which has more than 18,000 packages or more. And most packages have functions to make calculations. Like, for example, you want to calculate connectivity, or you want to calculate abundance, or you want to calculate stuff. But some actually may have just data. Like, for example, this Palmer penguins data, which is kind of like a pretty cool package. So let me I'm going to go here and change this for a second. Let me see if I... Okay, I'm going to try to go back to my R here. So how do I install packages in R? So usually, you can install packages here or here, but I prefer to install them here in the console, and I can do install packages. And I can do here, for example, Palmer penguins, and that will install the package in my R. Students often ask me, but why are not all the packages installed in R by default? It's just that there's too many, right? And sometimes, you're working with R, maybe you're using 10, 20 packages. You don't need 18,000 packages, right? So you start installing the packages as you start needing them, right? So once the package is downloaded into your computer, you can just simply say, and I'll write here a comment, say, I installed the package Palmer penguins. And now you can do library Palmer penguins, and you run that. And that means that all the functions inside the Palmer penguins package are now in your R, and you're welcome to use them. And one of the things that are inside this Palmer penguins data is, and I can do view. Actually, I'm going to do it here. So I'm going to do, let's see the awesome penguins data. You can do view penguins, and if there's justice in this world, you're going to get a spreadsheet. You're going to see all the cool data on the penguins. You have the species, you have the island, you have bill length, bill depth, flipper length, body mass, sex, and the year that the data was collected. So pretty cool stuff on this penguins data. So let me go back here to my presentation, and I'll go here, and I'll go here, and full screen. There we go. And these are awesome penguins. Who doesn't like penguins? Penguins are pretty cool. So here you have 3 species of penguins, Gen 2, Adderley, and Chinstrap. And you have different types of measurements. We have flipper length, we have bill length, we have bill depth. We also have the weight, also have the island and the year. And this is going to be as similar as a spreadsheet as it can be. So what we're going to learn now, it's a little bit of how we can just query stuff inside this spreadsheet. One of the most useful functions that I use almost every day in my research are the head and tail functions. So sometimes, data frames are super long or super big, and you only want to have a taste of how it looks like. So you want to do that, you can use the head function. And the head function gives you only the first 6 rows, right? Maybe it's a data frame that has thousands of rows, and you don't really need to see them all. You just need to see the first 6, and you have a better idea of what the data looks like. So usually whenever I'm uploading a new data frame and I don't know what it is, I just do head, the data frame, and boom, I can see the first 6 rows, and I know, it has a column called species, a column called island, another column called build length, and so on. And I can do the same thing with the tail function, but instead of the first 6 rows, it's going to give me the last 6 rows. In that way, I can see the first part of the data frame, and I can see the last part of the data frame, so I can have a better idea. Another useful function to deal with data frames is names. If you're only interested in knowing what are the columns of the data frame, you just do names and then the data frame, and boom, you get here the 8 different, the names of the 8 different columns of the data frame. All right. Oh, sorry, there's a question in here. Can you change the number of rows? Actually, I think you can, yes. So if you do, let's do that. So if you do question mark, head, parentheses, parentheses, you're going to see the help file for those functions. You might be able to like tweak stuff around and maybe do a little bit more, a little bit less. Good question. And if you don't have the option by default, because R is free as in candy, but also free as in speech, you can actually go inside the function and you change it yourself and add it yourself. And people do that all the time. They get functions that other people build and say, hey, I'm just going to make it better by adding this feature. So if that feature is not there, you can actually go and add it and just tell the package management, hey, I made this other like head improved, for example, and now you can just have something that you can specify the number of rows. But I'm pretty sure that that's probably there by default. Good question. What we were doing? Oh, so another operator that is super, super, super important is the $sign. And I think I'm gonna go back to my R. Sorry if I'm making you dizzy between one another, but this is kind of like an important one. RStudio. All right. So we're looking here at the penguins. Actually, I'm gonna lead by example and save this and say this is save this in the desktop and say this is, I don't know, our intro. Now it's there. And what was it? Oh, yeah. So let's say I just want to see the column on build length. So I will do penguins, $sign, and know that RStudio is smart enough to know that if you wrote a $sign, then now you want to select a column. So it's going to give you the different columns in the data frame. Isn't that cool? So you can just go and say, I want to see body mass. And you can just run that. You're going to get a bunch of numbers, right? Like body mass. Or I'm going to say penguins build depth. I run that. And I get the measurements of build depth. Isn't that cool? And of course, I'm going to write some comments here using the $sign operator. Practicing again. And now I can do calculations on that. So for example, let's say I want to see the mean of build depth. So I'm going to do mean penguins build depth. And let's see, what do we get? I get an NA. What's happening? It's just that the data set has NAs. NAs, it's missing data, right? Maybe it's a penguin that they were trying to measure and the penguin got away and they couldn't get that particular measurement. So one of the cool things about R is that it needs to be very specific. Okay, so in this case, I'm trying to get the mean, but it's just going to give me an NA because I haven't told R what to do in the case that I have NAs. So what I can do here is say, well, in this case, remove the NAs. I'm adding the argument to the function mean, say na.rm, that stands for na remove, and say equals true. And now if I do that, I will get the mean of this build depth, right? Oh, there's a question in the chat. See? What do the numbers in the brackets mean? What names in the names in the bracket? Sorry, I'm seeing this late, so I don't know if this was.
I think they're referring to the output when you pull up a column, like Penguin build depth, it has like 1 in brackets right there.
Oh, this. Okay, yeah. That's a really good question. So that's sort of the order in which they're output. So for example, this is the first one, and then 2, 3, 4, and so on. And this is the 25th one, 26, 27, 28, and so on. This is sort of an idea. So you can have an idea of how much items do you have. So in this case, I know that I have more than 337, 38, 39, 40, 41, 42, 43, 44. So I have 344 items here. Good questions. Yeah, thanks for that. It's just the order in which they are. All right. So I can have the mean. So calculate the mean. Oops. Okay, I can. So this is a help file. Sorry, I did something here. I don't know what I did. Oof. Give me 1 second. I'm going to fix this. But anyway, oh, here it is. Okay. So let's go back to the slides. Okay. All right. So are you seeing the $sign operator? All right, awesome. So we already did this. We already took the mean. And what else? All right. So we can now combine functions with logic. Remember the logic operators that we learned before, like for example, the equal or the greater than or the and or. So for example, if I want to know the mean body mass of Gen2 males, right? Gen2 is the species of penguin, and males is the sex of the penguin. So I can say, give me the mean of penguin's body mass where penguin species equals Gen2 and penguin sex equals male. And of course, I need to add this na.rm just to tell R to remove those NAs. All right? Everybody with me? And if I do that, then I have here the body mass only for Gen2 males. This is really super useful, right? Because this is harder to do, excuse me, if you have like a spreadsheet or something, right? In this case, it just takes like 1 line of code to do this relatively more complex calculation, but in spreadsheets, it's a little bit harder. All right, any questions so far? Oh, there's one in the chat. What is the difference between equal and equal? That's a really good question, Kelsey. So if you say equal, R is going to think you're assigning a value, right? If you do equal, then R knows that you're just checking to see if it's equal to this thing, right? So if you do only the 1, you're assigning something. And if you can try it, if you do only 1, it's just going to give you an error and say, hey, I don't know what to do. You're trying to assign something here, but I don't understand. If you do 2 here, then R will know, oh, you want to check that the species is Gen2. No, you're not trying to assign Gen2 to the column species. That would be if you only have one equal sign. Good question. Are there any other questions? All right, we're kind of like good on time. So I'm gonna show you how to do 2 simple figures, and then we are gonna have an exercise. And with that, I think you have your first introduction. So we're gonna do some exploratory data visualization. The first one is histograms. Not sure how many of you have seen histograms before, but histograms are super useful. I do histograms pretty much every day in my own research. They're useful to see the distribution of the data, the minimum, the maximum, and how they vary. So let's learn how to do that. So here is an example how to do a histogram of the body mass of the penguins, right? So I'm using the function hist that it's telling R do a histogram. And the different arguments of this function are first the data that you want to do the histogram on. In this case, I'm saying in the data frame penguins, use the column body mass. So it's going to do a histogram of whatever is stored in the body mass column. Main equals nothing. Those are empty quotes because main would be a title. So if I want to add a title, I would just add a title there. But in this case, I don't want any title, so I'll leave it blank. And then I'm adding a label in the X label here called body mass, and body mass in grams. And when I do that, I get this really nice histogram. And I know from the histogram multiple things. I know the variability, from less than 3,000 to a little bit more than 6,000. I know that most of the data, most of the individuals somewhere in here, but there is variability. There's some that are a little bit larger than that. So it's kind of cool to sort of have a really nice sort of zoom out view of your data. Any questions with histograms? The second one that I think it's useful to know in the first day that you use R is the scatter plot. Scatter plots are also super, super useful. We do scatter plots all the time. So in this case, I'm doing a scatter plot of build depth and body mass. And of course, I'm using here the function plot. And the first argument will go into the x-axis. The second argument will be the y-axis. Then I have the x label equal build depth, and that's what I have over here. The y label is going to be body mass in grams, and that's what I have there. And when I plot it, this is build depth by body mass. But now we have like two clouds of points. Why is that? Anybody has an idea?
Is it because there are multiple species of penguins in the data set?
Yeah, there are multiple species. There are also males and females. So here I'm only saying penguins build depth and penguins body mass, right? So I'm putting all the animals together. I'm not separating by sex or by species. So I'm just gonna get whatever it is, and likely, yeah, there's some relationships among multiple species. So now let's take the last 10 minutes or so to do an exercise. Hopefully, it's an exercise that sort of encompasses all the things that we've done today. So let's make a scatter plot similar to what I have here of build depth and body mass, but only for females of the species Gen 2. And I don't know whoever is recording if you want to like stop the recording or continue, but because there's going to be a space of nothing for the next 5 or 6 minutes.
Sure, I am happy to pause the recording for now.